Okay. All right. We are live. Thank you, everyone, for taking the time and joining today. And if anybody was in New York and was at the Ramp Modal Prefect event last night, that was also a really fun event. But this will be a little bit different. Same kind of theme: robust, durable systems, running pipelines at scale, all of those great things. We have 3 speakers today. I'm really actually excited about all of them. Should be a really good talk. We have Elliot from Pipekit. We have Qian from DBOS. We have Alan from Rasa, all really on a pretty consistent theme about running things durably, reliably, orchestrating these things in the cloud, getting them off of your laptops, and less about kind of the fanciness that agents can showcase, like fancy demos, more about how to actually get these agents running in ways that when they fail, they start up again. When they crash, they can come back. And you can actually get these pipelines running in reliable ways and start building blocks in your code base. Really appreciate all 3 of you coming on. We have 3 speakers today, and usually when we have 3 speakers, we are a little bit crunched on time. So I'm going to just let us jump into the first one. We'll start with Elliot from Pipekit. He's going to show us a better way to think about YAML and Kubernetes. And after that, we'll jump over to Qian and then Alan. But whenever, one second, Elliot, whenever you're ready, I'll let you jump right into it. Your screen should be available.
Yep. Okay. Hello, everyone. Welcome to my talk. No YAML, no problem. Orchestrate Kubernetes workflows the easy way with Python. So this is going to be an intro to Argo Workflows in Hera in 15 minutes or less. First, who am I? I'm Elliot, a senior software engineer at Pipekit and maintainer of the Hera open source project that I'll be talking about today. And who are Pipekit? So we provide enterprise support for companies adopting and scaling Argo workflows. We also have a control plane product to expand Argo to multi-cluster scenarios. You'll get direct support from active Argo workflows maintainers, saving you engineering time and compute costs. And here's the outline of today's talk. So first we'll give a brief overview of Kubernetes and Argo workflows before diving into Hera, its features and examples, and finally the key takeaways of the talk. So I'm sure everyone has at least heard of Kubernetes. It's the cloud-native standard and allows users to scale up easily. It's container native with an active community. You've got long-term support from big names, but overall the project is vendor neutral. But what you might not have heard of is Argo Workflows. And spot the difference with this slide. Argo Workflows is built on Kubernetes, so you'll see all the same benefits. It's become one of, if not the most popular workflow orchestrator, and so it's effectively the de facto standard. And the rest of these bullet points are the same from the previous slide. And if you want a mental image of Argo, it looks like this in a web UI. So let's take a look at the anatomy of a workflow. Like all things Kubernetes, workflows are custom resource definitions. So in this case, they have a spec, which this contains a list of templates. And you can think of these templates as functions in a library. You can arrange the templates in a DAG, so that's what we have here, calling this echo template. And there's also a sequential steps template. But the entry point here acts as the main function for your workflow. So what problems do developers face when using Argo? If you recall the name of the talk, we don't like YAML, it can be a barrier to entry. It's hard to test workflows programmatically, it's hard to reuse raw YAML, and for Argo itself, YAML just makes it hard to maintain long workflow files. You can imagine this fine-tuned LLM workflow containing hundreds, if not thousands, of lines of YAML, and what if there were an easier way? Here, we introduce Hera. It's the Python SDK for Argo workflows, which lets you write templates as Python functions, as well as the workflows themselves. And you can interact with the Argo Workflows API entirely through Python. So we get the best of both worlds. Python comes with a better developer experience, code completion, testing frameworks, and more. And we're using Argo, the best-in-class Kubernetes workflow orchestrator. We get a seamless developer experience from this, where Hera gives you the all-in-one solution for writing business logic, workflow orchestration logic, and your submission code, all from Python. Plus, it comes with the extensive documentation that was recently refreshed following a developer survey we ran earlier this year. But that's enough talking. Let's see some code. Let's see how we can recreate this basic DAG example written in YAML and rewrite it in Hera. Going line by line, we start with the custom classes that Hera provides, giving you better code completion and type hints. And next, you'll see the context manager pattern for workflows and DAGs. This mirrors the YAML syntax if we remember what we were just looking at. So it helps developers actually transition to Hera. They're looking at the same patterns on both sides. And then in the context manager, we see this container. It gets automatically added to the workflow. And then down here, we see the tasks get automatically added to the DAG. The DAG itself is also a template, so that gets added to the workflow. And to reduce boilerplate, we have a sprinkling of syntactic sugar. So this is a pseudo call of the function where you pass the arguments of the task. So see the difference with the previous slide. Here we have a task object where we're passing the template of, well, the echo template we just created, container, to the template variable. And here we just reduce the boilerplate. And finally, you see we can set up the dependencies of the tasks using this bit shift operator, which you might recognize from Airflow. Going back to the original idea, recreating the DAG diamond in Hera, which do you prefer? What you might not realize is the Python code on the left actually gets translated into the YAML on the right. This is because Argo is on Kubernetes, so it only understands the CIDs written in YAML, unlike something like Airflow, which is running the Python code that is there on the Airflow server. So container native is cool and all, but what about Python native? In Hera, functions are templates. All you need is this script decorator to containerize your function. Then you create a DAG in the same way as for containers that we just saw. And once you've got your workflow together, you can run it on the Kubernetes cluster through a simple workflow service and a function call. And we can actually use the object returned from the create function. Here we're just printing a link to the console, so we can click through. So this is an example that can run on local Docker desktop, so that's why it's a localhost. And on the actual UI, you can see the live progress of the DAG. So these three A, B, C are finished, and D is pending to run. The whole DAG is in progress, and then we see when it's finished, everything has run. On the right, we see a sidebar of details for the selected node of the graph. And you can also see logs and more details from the other two tabs. So we've seen the basic DAG diamond and how to recreate it in Hera. Now let me show you about one of the key features of Hera, the Hera script runner. But first, let's take another look at the function we just used in the DAG diamond. There are no types. Hera adds some JSON load boilerplate, but makes no guarantees on the type of the parameter. So this could be a string, could be a list, could be a dictionary. As long as it's valid JSON in the input string, it will get loaded and printed. So this is an inline script template where the function body is simply dumped into the YAML. So don't forget, Hera is a translation layer to the Kubernetes CIDs that Argo understands. You'll see any types that you add here, they have nowhere to go in the dumped YAML. This source field acts as a single Python file. So itself is not a function. So you can't have a return statement. You can't have input types. So how does the script runner solve this? It's a module contained in the Hera library itself, which runs your function. It handles all the input parameter parsing and validation. And all you have to do is build a Docker image, which is accessible from Argo. And how do we set it up? We just need to add two values to the script decorator, the constructor and the image. You'll then see the function compiles to a script template like we see on the right. The command is Python. It's being passed the Hera Workflows runner module, and that takes an argument for the entry point of your package's function name. So what do we get from this Hera runner? The main selling point of this feature is that your inputs are validated against the types that you provide. So the Hera runner is actually deserializing and checking that this is a float and this is a float. And you'll also be able to return values from the function. So that means you can test script templates like any old Python function. This addresses one of the biggest problems of using plain YAML workflows, as you would otherwise have to test the template directly on the cluster and use your eyes to check what is going on. So let's take this up a notch. If you've been using Python for some time, you'll have heard of Pydantic. Pydantic is a data validation library, which is really good for APIs, where you want to translate from JSON to Python objects and back again, and make sure they have the correct structure and correct types. So Hera already actually integrates with Pydantic for general type validation, like the floats that we just saw, but you can also use Pydantic base model classes for your template inputs and outputs. This gives you better Python type hints and auto-completion during template development. And at runtime, the Hera runner uses Pydantic to automatically deserialize JSON inputs into type-safe Python objects and serialize Python objects into the JSON outputs. So let's take a look at how we can use a Pydantic base model class in this basic example. So we're going to create a rectangle class to replace these two input values. So first we take the base model and create a subclass from it. And we're going to give it its own function. So we're actually doing something inside this class. And then we use that class as an input to the function. And that means you can test it like normal. In the world of Argo, this is almost groundbreaking. In the world of Python, it might not look like much. And so what if you need binary data inputs or outputs? Well, you can do that too by passing user-defined functions in the type annotations. So in this example, we're annotating the return type as a pandas data frame. And by using the annotated type, we provide a metadata in this section of the artifact. It sees this dump b function and turns the output of the function, a plain data frame, into a binary Parquet file. So a quick fire round of more things Hera can do for you. We saw earlier how you can interact with the live workflow object on the cluster, which opens the door for checking execution path through the DAG and checking outputs of individual steps. Hera has a built-in mechanism for common setups and config, such as default resource requests, image pool policies, and more. So this can help a platform team in your organization create a wrapper package around Hera, which suits your organization's needs. And finally, if you want to version workflows, you can piggyback off Python versioning, which makes it easier to know what's running on your cluster. For the key takeaways of today's talk, so Hera helps you avoid the headache of YAML and makes workflow orchestration on Kubernetes accessible. If you're using Python, then Hera can supercharge the developer experience of Argo Workflows. And finally, linking back to the title of the summit, if you want to train AI that doesn't break, you'll need data pipelines that don't break. The TLDR of all this, Argo Workflows and Hera can give you the best cloud-native workflow orchestration experience. If you'd like to connect with us on the Hera project, you'll find us on GitHub under Argo Project Labs/Hera. So please come and suggest features, report bugs, and contribute code. We'd love to see it. And if you want to learn more about Hera, the docs are at hera.readthedocs.io. And finally, we have a semi-official Hera Slack on the CNCF community, but I'm also on the MLOps.community Slack if you want to DM or tag me. And finally, some free stuff from Pipekit. We have all our previous talks from other conferences available on the Pipekit/talk demos repo. And if you're using Argo Workflows already, we have a free workflow metrics product, which will help you get started with better observability. And that's all from me. Thanks very much.
That was awesome. This is actually really, really cool. I guess I didn't know this existed, and maybe it didn't exist back when I was using Kubernetes, which was a company from a couple of years back. This was actually the exact thing that we were looking for. We ended up not being able to go with Argo because our system and our customers were so Python native, but we ended up using Airflow, which we weren't particularly happy about. This was literally the thing we were looking for. I don't use Kubernetes anymore, but for my current company. But that's a really cool thing. That's amazing. How long have you personally been working on this project?
I think about 2.5 years now. So I was at Bloomberg before Pipekit, and we had the same problem of Airflow versus Argo. And we found the Hera project was in its infancy, where Flav was maintaining it. And he let us come onto the project and kind of start helping. And we helped rewrite the library for a version 5 major release. So then it was fully one-to-one with YAML with the spec, whereas before it was a much more simplified data engineer approach.
How have you seen the adoption of it? What kinds of teams have been adopting this? Are they smaller teams or larger enterprises, or kind of a mix of the two?
Definitely a mix of the two. We're seeing loads of big companies using it, ones that are surprising me in terms of hedge funds and other financial institutions. Obviously, like Bloomberg are also still active on the project, but we've also seen startups that we work with adopting it and just finding it really much less painful than YAML.
That's cool. Yeah, I would have. My guess would have been mostly larger enterprises, people who took that shift to move on to Kubernetes and were trying to be ahead of the game of the trends and really get onto a scalable system, and then got there and then got stuck in the world of YAML. I could imagine a lot of people wanting to quickly build this up. That's awesome. Okay, thank you so much, Elliot. Qian, we're going to jump over to you, and we'll save some other questions for the end.
Sounds
Your
good.
screen should be ready. Yeah, so go ahead whenever you're ready for it.
Okay. Hi, everyone. My name is Qian. I'm the co-founder of DBOS. And today I'm going to talk about how to build reliable AI applications with durable workflows. And I believe, and this actually our company's belief, is that your database is all you need. Cool. Let's go. Let's go next slides. So here is an example AI application. It's actually a very typical use case we've seen. So for example, if you want to build a document extraction agent, you may have a user interface which takes input from user, says, I want to summarize this paper and I want to answer some questions. And then the AI model will dynamically construct a workflow saying, okay, I'll first download some PDFs from the website, download some papers, and then I'll index each page of the paper, and then they'll generate vectors and they'll store those vectors in the vector database, store vector embeddings in the database, and then I'll use them to answer user questions. So that sounds really simple, and you can easily build an AI demo or some kind of very simple AI prototype with any of the AI frameworks. But the tricky part is that any step can break, right? Your process may crash. When you download, it may run out of memory. When you index a page, you may have a bug where you generate the wrong index. Your database may become temporarily unavailable. Your AI model may return 500 internal server error. And also, your user may not be as reliable as you think. They may take, if you need a human verification step, they may take a bit too long to respond. So you have to consider all the challenging scenarios. So you may ask, okay, those are already challenges for software engineering. Why do I have to care? So the problem is that AI-driven workflows make things even more challenging. So the thing we've observed is that AI-driven workflows are extremely dynamic and long-running. So you can't typically write a static DAG or statically define a workflow graph for it, because the workflows are often driven by the LM decisions. Say the LM will tell you, I want to call this tool and this tool dynamically based on your user input. And secondly, LLMs or external API calls can be really unreliable. And because those AI agents are increasingly interacting with external world, like helping you to book tickets or interact with your database or interact with other services, they can have unreliable performance. Sometimes it will take 5 minutes or even longer to respond. And then many APIs would have rate limits. Say you can't call the LLM more than 50 times per minute. And then they often have transient failures, and then they often sometimes will give you wrong results. And moreover, as I mentioned before, even with AI, those autonomous workflows usually require human in the loop. So sometimes you need to send an email or send a message to some admin or human or user to verify the workflow. And then the workflow will have to wait for user input before going. And finally, those workflows are extremely large scale. Sometimes if you want to crawl the web, if you want to do some deep research agent, it will have to crawl hundreds of thousands of documents and then process hundreds of steps. So to solve all these issues, we can apply our traditional wisdom to try again. If something fails, no problem, we can try it. But it doesn't usually work for AI-driven workflows. First, if you try again, some completed step may run again, so you may get data corruption or you may have duplication. For example, if your agent needs to send a user email, then if you try it again, it will send the email again, and users will become very confused. And moreover, you will waste your compute resources, and those AI models are not cheap. So if you keep retrying, you will burn a lot of money. And finally, retrying could be really slow. So what should we do? Then I'm sure all of you play games. So when you play games, you always want to say, I want a save point. So if I take a break, if I go for dinner, when I come back, I don't have to always restart my game from the beginning. I can just resume from where it left off. So that's exactly is the idea of durable workflows. So basically, durable workflows checkpoint your program's execution state so that it can resume from where it left off. So here's a concrete example. So in DBOS, we built a durable workflow engine as a library. You just write normal functions. Currently, we support Python, TypeScript, and we're developing Java and Go. And then you just say, for example, I want to index some document. And then you can just decorate this indexing workflow as a DBOS workflow. And then for each step in the workflow, for example, first download the document and then we'll index the document using LLMs, you can decorate each individual step as dbos.step. So what's the difference between a workflow and steps? So workflows need to be deterministic. For example, if I crash in the middle when I restart from the beginning, the workflow will follow the same path. But it doesn't mean that the workflows have to be static. So basically, you can be dynamic as long as your control flow is deterministic. And then for any non-deterministic logic or any external calls, LLM calls, you can wrap them in a step. And for step, you can also configure retries with exponential backup. So the step and workflow are two basic building blocks for DBOS and for most of the durable execution engines. So how it works, right? So basically, when we execute a workflow, we first checkpoint a workflow input in a database. And then after executing each step, we checkpoint the steps output in the database. And say, if I'm executing step 3 and the machine crashed, I have to recover it. And it's fairly simple if we have durable workflow. So basically, when we recover the pending workflow, we take a look at what had finished before. And then, because we recorded the workflow input, step 1, step 2 in a database, we can safely skip those completed steps and use the recorded results from the database. And then we resume the execution from step 3 and then run it to completion. So that's how with durable workflows, we can resume from where it left off. And you may have heard of other workflow engines or durable workflow engines. What is different? Why DBOS is different is that we believe your database is all you need. So DBOS runs in process in your application code, in your application process. So there's no separate orchestration servers or workers. As long as you install DBOS library, use the library and connect it to a database, for now it's Postgres, then you're good to go. DBOS will automatically checkpoint the annotated functions, inputs and outputs to the database, and then automatically recover when your workflows break. And it's really simple to integrate with existing programs, and it's easy to integrate with AI frameworks. So I'll have some concrete examples later. Moreover, besides durable workflows and steps, we have other database-backed features. So it turns out that it's really simple to implement workflow graph tracing because we store the inputs and outputs of those workflows and steps. So you can extract those data from your database and then construct a visualized graph. And then it also makes workflow control super easy. So if I want to fork a workflow for, say, my step 3 is buggy, I want to deploy the new code, but I don't want to repeat step 1 and step 2, then you can fork the workflow from step 3 by leveraging the previously recorded result, but running the new code to resume the workflow. And you can also do workflow cancel and resume easily to recover from failure. And we also implemented durable queues to deal with rate limiting and concurrency control when you talk to external APIs. And it's also easy to implement durable sleep for long waits. And we provide durable timeouts so that we can actually bound the workflow to, for example, to not run if it's beyond 1 hour. And we also have durable events to durably wait for human input and other external triggers. And we also provide durable cron jobs. So when I say it's really easy to integrate with AI frameworks, actually we have a blog post about it. So we showed how to use DBOS, for example, with LangChain to build a reliable refund agent. So all you need to do is here use the process refund function. You can construct a DBOS workflow by decorating it as a DBOS workflow. And also you can tell the AI agent to use it as a tool by decorating as a long chain tool. All right. And then so you may ask, where can we use this durable workflows in our applications? So actually it's really flexible. And also because DBOS is so lightweight, you can use it essentially anywhere. Here are the 3 top common use cases we've seen. The first is data pipelines. For example, you want to index PDFs or index websites. You may want to make your data pipeline durable so that when your process crash or out of memory, you don't have to re-index the previously completed steps. So you can resume from where it left off. And then secondly, you can also use durable workflows to drive your AI main loops. For example, in the loop, you can orchestrate LLM calls and ask your LLM what next steps should be. And then based on the output, you can call those tools durably as durable steps. And finally, you can also implement your tools with durable workflows for MCP servers and agents. So each of the tool calls can also be a sub workflow to implement a checkout flow or implement an email notification flow. So finally, with the last 2 minutes, I'm going to walk you through a concrete large-scale production AI agent use case. So this is actually an production AI agent running like hundreds and thousands of workflows right now on DBOS. So this is a autonomous AI agents that monitor the web. So the users can say, I want to monitor the price of flight ticket, and then they will launch a fleet of AI-driven workflows to periodically crawl the website and finally email users about your updates. So it looks like the workflow I've shown in the first slide, but it's in production, so it's quite complicated. So the users say, I want to track flights to Tokyo under 900 in August, and then the LLM will parse that question and then construct a workflow specifically for that user. For example, it will first crawl relevant websites, and gather all the relevant information, and then store the information in a database, and then trigger the second step, whereas to extract those information and understand what's going on, and then store some of the insights in the database, and then pass it to the next step, for example, to format your information to figure out the diff between previous crawls, and then finally send a user email for the update. And when the users came to DBOS, they already have some of the workflows built up, but their system is not super reliable. So here are the challenges and how DBOS helped. So first, all of their workflows are dynamically generated, so they cannot use the static DAG. And also, those workflows are really long running. For example, they may wait for a few days for user input or for some response from certain external APIs. So they use DBOS workflows for overall orchestration, and then they use steps for individual LM calls or API calls or any non-deterministic or external interactions. And then they also use durable sleeps for long wait. For example, if they need to wait for external additional user feedback, they will, for example, sleep for 1 day and then check if the user has responded yet. And then to handle unreliable LM calls, they use DBOS steps with automatic retries and exponential backoff. And then they also want to make sure that they email users exactly once, because if you don't email users, people will be very confused. They may think your agent doesn't work. And if you email users more than once, then they may think it's kind of unprofessional. So to solve this, they use DBOS steps with built-in idempotency key, so they can check whether email has been sent before or not. And then they also have many parallel subtexts tasks. For example, when you crawl the website, you want to crawl them all in parallel. But you also have to be careful about rate limits on some of the websites. So that's why they use DBOS durable queues, and they also use child workflows to parallelize those tasks, and then to control rate limits and concurrency using the queue interface. And finally, they also have periodic tasks. For example, if I want to monitor the price changes for tickets, I want to run this workflow every hour. So they use the DBOS durable cron jobs. And then because everything is based on a database, everything is persistent. So even if some of the process crashes, we'll always resume from where it left off. If you have a long sleep, we'll make sure you never oversleep. And you have a cron job, we'll make sure that everything will run in schedule. So in summary, your database is all you need. Your database can be your durable engine. Your database can be your durable queues. And if you want to learn more, please visit our website and check our open source libraries and meet us on Discord. Thanks.
That's awesome. Thank you, Qian. I am super stoked about DBOS. I think it's a really, really cool project and fits like really well in the world that's kind of emerging of one, like separating compute from storage, two, like owning your compute, owning your execution engine, and three, just like moving back or re-emerging the world of just like Postgres for everything. I really love the energy of Postgres for everything. It's such a cool concept, and it's so unbelievably dynamic in what it supports. We got two questions from folks about your talk.
Mhm.
One, the second question we got was, over what infrastructure was the AI agent running? So I think they're asking about when you ran that fleet of models that was checking the flight, both like where was that running, and then also where, like what was the brain that was actually scheduling these things to run and pick up and continue?
Right. So as I said in the talk, everything is open source. So the brain is in the open source library. So basically, when you start a process, we'll start some background threads to check the database to figure out when to schedule those things. So you don't need an additional scheduler or orchestrator. You just need to embed DBOS library into your process, and we'll use the database together using the database to figure out the schedule. And then for the production AI agents, so DBOS is open source, so you can run it anywhere. But in this specific case, they're actually using DBOS Cloud. It's a serverless cloud we provide. So they're hosting on our platform, but we also have great self-hosting support. So you can essentially run DBOS anywhere.
When you say, just because he asked about infrastructure, just to tie up on that comment, when you say you just embed DBOS into anywhere as the brain, for example, that could be like an EC2 instance that you spin up, right? That has a connection to your Supabase or your Neon database.
Yes.
Cool. And the second question you got was, how does DBOS's checkpointing system into Postgres differ from LangGraph's checkpointing system? I actually don't really know about LangGraph's checkpointing system, but I imagine you do.
I briefly read about it, but I could be, don't quote me on this. So my understanding is that LangGraph requires you to statically define a graph. And then it will checkpoint some. So the idea is similar, but DBOS design is more general. Like you can just decorate any Python function and you don't have to specifically spell out a graph. Yeah, and also we provide all the durable queues and other features that LangGraph doesn't provide. So as I showed earlier, let me see quickly. So we actually build an agent together with LangGraph. So for the outer loop, you can use LangGraph, but for individual tools, you can use DBOS. So it's very flexible in terms of like how you use it.
Right. Yeah, and I think, I mean, everyone's going to have their own opinion, at least from my experience using these tools. The more general the tool, the less opinionated the tool, the better it tends to be to work with. In many ways, LangChain might be, or LangGraph might be like an implementation of checkpointing specifically for running LLMs over a set of tasks,
Mhm.
but there's a whole bunch of other things that have to happen that aren't just like the LLM calls. Here we got another comment on this. LangGraph checkpoints execution as well and allows node retries. It doesn't allow the whole graph to reboot. Okay, that's interesting. So yeah, I mean, I think that you can imagine DBOS, obviously Qian, correct me, but like it seems like DBOS is much more where it can be your overall system, not just the parts of AI, but everything that needs to run in code can be run and managed and checkpointed and retried and scheduled and everything through DBOS, whether that's like an endpoint request or whether it's an LLM request or whether it's, you know, some pandas or polars data manipulation. Is that fair?
Yes, that's correct.
Awesome. Go for it. You had one more comment there.
Oh, I think you summarized really well. Thank you.
Okay. You got one more question, then we'll jump to the next talk. How would this couple with Gen AI kits on major cloud providers, for example, GCP agent LangGraph deployments? Similar question, but maybe a different.
Yeah, so I think because basically DBOS can be used in any workflows or any Python functions, you can imagine some part of your tools will require durability. And you likely will, for example, when you talk to external systems, when you want to, for example, send an email or scrape the website, you can just use, you may not be able to write everything in a single framework. So that's how you can say decorate this Python function with DBOS and then use this function as part of the tool call. Like when you provide a list of tools for your agents, then you can say, this is a DBOS decorated function. I'll use that as a tool.
Can you just use a DBOS step without a DBOS workflow? And that
sure, you can. So DBOS steps will be retried from the beginning. So if you and DBOS workflow will give you finer checkpoints capability.
Right.
So there's a balance there, definitely. So if you say this is a single API call, then sure, this is a step. If it fails, we'll just retry the entire step. Yeah.
Got it. Okay. Awesome. Very cool. Thank you, Qian. Alrighty, Alan, we're gonna jump to your talk, and then we'll bring everybody on for community questions. Whenever you're ready, yeah, kick it off.
Absolutely. Yeah, I get to bring us home. Well, thank you, and well done to the previous two speakers. I'll try and keep up the pace, keep up the energy a little bit, and talk about an idea that I think is sort of bubbling up in the community, and I see it in other places, and I'm trying to give it a name. And so that's this idea of process calling. Very briefly about myself, I'm co-founder, CTO of a company called Rasa. I've been called the OG chatbot framework, doing chatbots for quite a while, and care a great deal about building robust and reliable conversational AI that I think fits really with the theme of all the things that we're talking about today. So I also really appreciated the perspectives of the previous two speakers. So this is the take that sort of sets us up for this talk, which is really in the context of like customer-facing agents, right? Which is one of the main use cases for Rasa. It's not the only use case for Rasa, but things that are sort of agents that are representing your company or your organization to some external people, right? To some customers. And my take is that function calling or tool use or whatever you want to call it is actually the wrong abstraction for that kind of use case, and you need something else, which I'm seeing emerge in a few different places, and I'm starting to call it process calling. And I will use the words like function calling and tool use and function use. I will use those interchangeably. Some people might, claim that there's a difference between them, but from my perspective, they're the same thing. And so I think this is in the context of, this idea of the augmented LLM. So this is the diagram from a wonderful blog post by Anthropic, that really clearly explains, some of the key techniques that people are using to build agents, things like RAG, things like tool use. And so they explain it as, you have this LLM and you get to augment it with additional things, right? So you get to augment it, with retrieval to pull fresh information, with tools to read and write data to some kind of system of record, right, an API or something like that, and you need some kind of working memory. And I think that this diagram, it needs another box. It's missing something really essential beyond just the retrieval, the tools, and the memory. So just very, very quickly, just to ground us on what we're comparing against, or what our starting off point is, right? So one of these things you use to like augment what an LLM can do is this idea of tool use or function calling. And the idea is that you equip the LLM with the ability to read or write some data to the outside world, so that if you go to your agent or your chatbot or whatever you want to call it, and you say, show me my GitHub issues, right? Of course, just a fine-tuned LLM that somebody trained couldn't possibly know what those are, so they're going to go and call some API, right? So it has the ability to say, hey, look, I've understood the user's request, I've understood that I have a source of data where I can retrieve that information for them, so I'm going to use that. And we're wrapping that actual raw API call of like listing GitHub issues, we're wrapping that in some glue, right? Because you got to extract some parameters from the user's question, and you've got to take something from the output and like formulate it into a nice answer and all that kind of stuff. And so MCP is an emerging standard, and I think a very popular topic right now. And it's a way of standardizing this kind of interaction pattern, right? So historically, if you're a developer and you had to integrate some APIs, you would be writing that glue code. You would be, formulating the right parameters for your request, and then you would get some JSON back as a response, and you would take out the parts that you need and like do something with it, right? And, for the purposes of this talk, I think we just need to know that MCP is a standard way of implementing this pattern. And then specifically what I would say about it is that it means that you don't have to write that glue code, because instead you're going to tell the LLM, here's what the request should look like, here's what the response is going to look like, and kind of let the LLM do that data sort of manipulation for you, right? But it's a very nice idea, because then other people can publish kind of ready to use APIs that if you're building an LLM based app or agent, you don't have to write a bunch of this glue code. But here's kind of the key piece. So there's this key idea in the MCP specification, which is that tool operations should be focused and atomic, right? So something like list my issues, or post a comment on a particular pull request, or just one small thing, do read or write one small thing. And I think that's the wrong type of abstraction, the wrong thing to be using when you're building a customer-facing agent. So when people come and they talk to an organization that they're not part of, they don't speak the right lingo. They don't think in terms of like your backends and your operations, right? So this is a classic use case. This is customer support for an e-commerce website. And people don't come in with a perfectly specified request, like, list my GitHub issues. People come in and they describe their own reality, and they say something like, hey, you messed up my order. And that, that could be many things, right? There could be many core issues that this person's unhappy about. It just hasn't been delivered yet. It has, but it was late. There was something missing. There was something wrong in it. Something was damaged, right? There's so many things that could be in there. And any business, any organization is going to have pretty strong opinions about how they want to handle each of those different cases, right? This isn't like unknown stuff. They have a pretty well-defined process for, for particular types of customers, how they want to handle all these cases. So in this case, for example, if we kind of play this through, in this case, the user had a missing item, right? The phone case that they ordered wasn't part of it. So we're going to have to go and call some backend systems to figure out what happened. And we look at our fulfillment API, and we look at our delivery API, and we check all this out, and we realize that actually, this shipment was dispatched in 2 separate boxes, and the first one has arrived, the second one's on the way. It's coming, but it's not there yet. And then we're going to go fetch some information about this particular user, and we realize that they're not a scammer. They're like a good faith user. They have good loyalty with all of that stuff, and like we want to be proactive and offer them something nice, right? So we're talking to a bunch of different systems and have some conditional logic, and we are stitching together this experience of what we should be doing in this particular case. And so if you try and do this in an atomic tool type of scenario, you just have these tiny units of functionality. Like I have an API that can tell me, the delivery status for this particular delivery. I have another one for my fulfillment API, which lists the deliveries given a particular order number, like all this kind of stuff. And so the way that you would implement this in a tool calling paradigm is what I would call prompt and pray. So you get this pattern where you get an LLM to produce sort of intermediate text, right? And people call this like thinking. Let's leave that aside for a second. The point is it produces some intermediate text that says, that sort of, is kind of reasoning through, okay, what's the thing I should be doing next, right? And it's then deciding kind of autonomously, I should use this tool. Now I'm seeing this output. Okay, here's the thing that I should be doing next. And it's, this is very neat and it's very cool. And, if you have a use case where this is genuinely dynamic all the time and you need to be improvising all the time, then, this is the way to do it. But it's also very flaky and it's very difficult to use, right? I mean, anyone who's played with this realizes that, extra steps kind of appear or disappear randomly. Questions get asked in random order every time. And the worst part is you can only debug this thing via trial and error, right? So, okay, you look at some of this intermediate text, you're looking at traces, you have some observability, you're looking at the thought traces, and you go, okay, well, this time I see that it did this. Why did it this time decide that it should also verify the order contents first? Maybe if I change this in the prompt or add some additional information, it will do that or it won't do that next time. And it's just a game of trial and error or a game of prompt and pray. And the challenge with this is if you're a sizable team and you're not building one or two use cases, but you're trying to build coverage for, the hundreds of different things that people come and ask your customer service system, your development velocity very rapidly drops to zero because you're constantly introducing regressions. You're constantly trying to chase, why was it that the system did this on this particular instance and it didn't do it the other time? And how do we get this sort of soup of information that we put into the prompt to behave reliably? So the process calling thing is nothing really that special. It's just saying, let's think about a different abstraction and a different way of interacting with APIs when we're building an LLM-based app, right? So with process calling, the LLM invokes not a single atomic tool call, but it invokes a stateful process, right? So aside from that, it looks a lot like a function call, right? It just says, okay, I have this tool at my disposal. It happens to be a stateful tool. It's going to guide me through some steps. And then for multiple steps, and by steps, I mean, like back and forth with the end user, right? For multiple steps in the conversation, it's driving the control flow through that process, right? So it has some shared state with the LLM, it's reading, writing some data, and the process is the thing that's actually interacting with the APIs. So the process is the thing that's defined, by the business, and they say, for a missing order, a missing item in the order, first go check if it was dispatched in separate orders, and then go check the delivery API, and then check what kind of user it is, and then use that information, to follow these next steps to recommend something, right? And then when either, this process is completed or the user kind of interjects and says, hey, no, actually, I wanted to do something else, or, switches to another context, in that case, the process goes away from the context again, and you once again have the ability to either invoke a tool or another process or something like that. But it hangs out for multiple turns, right? That's kind of the key thing. And if you go back to that Anthropic post that I lifted, the building effective agents is the name of the blog post. That's where I lifted that initial picture from. They have this idea of workflows, which sounds a lot like kind of what I'm talking about with process calling. The key difference is that what they describe as workflows is you have a single user message that goes into the LLM, and then you have like this Rube Goldberg machine of all these things that are going to happen afterwards, right? You have all the steps that happen in response to one user message. But they don't talk about the really interesting case, which is, well, actually, you now have a stateful process, and it's going to persist, and you're going to have to guide the user, ask them some questions, and guide the user through some kind of process here. So, the key thing, and this is, I think important, especially if you have worked in conversational AI for longer than the last 2 or 3 years, important thing to understand is that when we define a process, we're not defining like, here are the possible conversation paths, or one of these like horrible flowcharts that people used to build of, what if the user says this and what if the user says that. It's not describing the conversation, it's just describing the business process. So only kind of like one encapsulated piece of logic, right? And so for a task, a process just describes what information do I need from the end user, what information do I need from APIs, and like any branching logic that I have based on the information that I'm gathering through the process, right? And so the way to frame this back to the original idea of like function calling, process calling, is that function calling is just a special case of process calling where the process has just one step, right? So a process is just a fancy function that's stateful and has multiple steps and hangs out for a while and drives the conversation forward. And it's a far more scalable approach than the sort of prompt and pray approach to building, more advanced, more sort of scaled up AI agents. I mean, and then it kind of feels ridiculous that this has to be a selling point, but it's actually a pretty important one, is you get, reliable deterministic execution of business logic, right? You don't get like 80% of the time it's right. You get it always that it's right? It means you can build true modularity, so you can truly break up processes into sub-processes, so you have like reusable pieces of logic, right? In a system where you have like LLM control flow, you don't have true decomposability, right? This goes back to like DISA. If you can't determine the entry and exit conditions for a piece of code, you can't reason about it and you can't use it as a true module. It means that debugging is straightforward because the process is either being followed correctly or it's not. You're not sort of squinting, looking at traces of LLM outputs, trying to guess and divine what it is that was going on. And you get some nice non-functional gains as well. You get a lot less token use and a lot less latency because ultimately, your business process is something that you already know up front. So you can just write it down rather than laundering it through an LLM and hoping that it survives the trip through the laundry and comes out intact. So it's also just a much more efficient way to run things at scale. So kind of going back to the original point, I think at Rasa, we're certainly not the only ones thinking about this, and I'm seeing this sort of pop up in other places. And so I think it deserves kind of its own name of process calling, and it deserves a box in those posts of like, here are like common patterns for building agents, because it is becoming a common pattern, right? I'm seeing it in other places. Specifically, in Rasa, we have a framework called COM for building, AI agents, and process calling is sort of one of the key tenets of it. It's not the only piece of it. You have lots of other things around, having a fluent conversation and how do you deal with sort of changing context between these flows and orchestrating across like RAG and flows and those kinds of things. So there's lots of stuff that happens to build like a full conversational AI framework. But this kind of key idea of process calling I'm seeing kind of, crop up more and more commonly. Keeping an eye on the time, I'll have to skip the demo for today, but hopefully we have time for a couple of questions.
Wait, I think if you want to run through that demo,
finish.
Alan, are you able to hear me?
Yeah, I'll just finish and say if you want a fun prompt and pray sticker, just shoot me an email. I'll happily send one. I've shipped them to all sorts of different countries, and thanks for listening, and look forward to any questions.
I think that you can run through that demo if you'd like. We have the time.
Okay, let me see if it's up and running, because I'm now in a different browser, so this is gonna have to be.
While you're pulling up your screen, I'll drop in a question that we got about Rasa. So it says, we've been thinking about similar concepts at Sequent, more from a DAG perspective, where tools are combined into a graph of processes instead of a linear chain of processes. Makes sense? For example, after running a tool, you can use tools B and C, but not tools D and E. Also makes sense. Does Rasa allow defining such kinds of graphs and validating them? Do you have integrations with LangGraph?
Yeah, all good questions. And I don't know why my UI is frozen. So I will post a link to a demo on YouTube that so people can check it out afterwards. Remind me of the question. I was busy trying to get the instance up and running.
does Rasa allow for defining those kinds of graphs where they're more of a DAG and less of linear graphs where, for
Right.
example, you can run a tool
Yeah.
A, based on the output, you can call some other tools, but not other tools?
Yeah, no, that's valid. So it's not even a DAG because you can have loops, and loops are actually can be very, very useful and very important, right? So you can do lots of very simple things in a nice way with just like a single step that kind of loops and asks the user if they're happy or something like that. So yes, and the nice thing is that you can build out these little processes in as small of units as you want. So one of the common things is, at the start, you need to authenticate users. At the end, you need to, you want to send like a quick feedback survey to see if the person was happy or if they're willing to sort of follow up and give some more feedback. So kind of being able to reuse those bits of functionality and compose them together is sort of a really nice way to also scale out your implementation.
And I think the secondary question to the follow-up was, what is if you have an integration with LangGraph, what is that integration?
I can drop a link to a demo where we kind of share, I think we compare side by side, one of the LangGraph demo apps, and then we kind of re-implement it in the sort of process calling paradigm, which might sort of answer some of the questions. I mean, we do a bunch of stuff on like Rasa orchestrating, across different types of applications, right? Because I think one of the interesting things is, okay, if you have sub agents that are potentially built with different technologies, how do you smoothly have a conversation that integrates all of those skills, right? So if each of them is truly independent and you just need to route the user to one of them, then it's an easy problem, right? But I think one of the things that we try and do well with Calm at Rasa is, okay, how do we share context across those different use cases? And how do you have a fluid conversation that sort of, allows users to not worry about like which sub agent they're talking to at any given time and just sort of, talk as if they were speaking to another human. And so we have some things coming out. We have a tutorial coming out in the next couple of weeks on doing that kind of, smooth integration with some process calling, with MCP, and with A2A. So kind of, throwing it all in the kitchen sink, like showing how you can, orchestrate all these different pieces. And I kind of like the idea of maybe also, maybe one of the things that we orchestrate in there could be a LangGraph bot, and I think that could be a nice addition to that tutorial. So it's a good question.
Very cool. And Alan, if people want to reach out, what would be the best way to get in touch with you?
Yeah, just reach out and ask for a sticker. It's just alan@rasa.com, and I will send you a sticker.
Stephen asked if you've tried using DBOS for your state checkpointing within Rasa.
I am learning about DBOS for the first time today, but it appeals to me. So there's a lot to be said for it. So I'd love to check it out.
That's awesome. Would love. I think the community, or certainly I would love to see that collaboration. That would be very fun to see two tools coming together.
Something that we that's definitely a strength of DBOS, that it is something that we don't do particularly, is sort of this truly like async, hey, I'm going to go do something and I'm going to pick it up again like in a day or a week or something like that, right? I think that's very, very compelling and interesting. So I'd love to, work together, Qian, and maybe we can build a tutorial or something.
Awesome. Yeah, I see a lot of synergies between Rasa and DBOS.
That's awesome. All right, we're coming up on time. We have 1 minute. Any final comments or words? Anybody? You guys can all share. Maybe just go around where people can get in touch with you, reach out, learn more about the respective things that you're building in the community. Alan, you can kick it off, and then we'll go backwards from the order of the speakers.
Good. Yeah. Just my call to action would be, don't just prompt and pray. There are better ways to live. And, don't pull your hair out trying to make these things viable. Like that's if you're architecting a system that involves an LLM, think about what part of this system is genuinely dynamic and going to change every time a user interacts with it, and encapsulate that complexity with an LLM. And for everything else, just build traditional software. And then my call to action would be, if you disagree with me or just want to chat, just shoot me a message.
So on my side, as I presented, our belief that your database is all you need. Durable workflows should be really accessible for everyone. It should just be lightweight as a library. So my call to action is please try DBOS, give us feedback, hang out on Discord with other users. If you want to reach out, let's connect on LinkedIn. Happy to chat, happy to help.
Cool. And me going last. I was getting worried as I was watching Qian's talk that we were on competing technologies, but it seems like they have a place to live in the world. So durable execution for that long-term aspect versus Argo Workflows with something that you want to run on Kubernetes in a short time period. You can find me on the CNCF Slack and Elliot at Pipekit.io, and also on LinkedIn, Elliot Gunton. There's not many Elliot Guntons in the world. So.
Awesome. All right. Thank you all three for presenting. These were really, really awesome talks, really well synergized, I think. And thanks for everyone for coming on and listening with us. We'll see you in the next one.
Thank
Thanks,
you.
Anonymous Ben.
Bye, folks.
Thanks very much.